Good morning, everyone. Am I audible to you? Hello, am I audible? Okay. Just a second. Hello. Okay. Everyone, please again, like our last class, please take out your copies. Like you have written the last class notes, so that we just don't skip anything. Okay. So I think you are coming from 27. That is Wednesday. We have class, so you are coming from that day. So we will again continue physically in the class here. So today, you please take out your copies. We will start from where we have left last class. Okay, let me share my screen. Okay, so last class we have you have written up to telemetering rain gauge. Yes, storage rain gauge and telemetering rain gauge you have written. So today you write down two more types of rain gauges are left. That is your radar measurement of rainfall, and the other one is your automatic radio reporting rain gauge. Okay, these two rain gauges today you write down. Okay, so rain gauges part, the types of rain gauges part, we will finish it up. Okay, we will not again repeat it in the class. So today you write down this one, radar measurement of rainfall. Everybody please write it down because later you will not find this PDF again. So I am giving it now itself. So better if you note it down in your copy. And when you if you finish writing, please mention in the chat box so that I can continue. Okay, you write down radar measurement of rainfall. Everyone write down. Is it finished writing? Radar measurement of rainfall. Please mention in the chat box, or you can speak also.
Yes, ma'am.
Finished? Okay. Okay, then if you have finished the writing part, please draw this one. Finished drawing? So basically, this radar measurement of rainfall, radar, as you all know, that radar is your what? Radio detecting and ranging. Okay, the full form is the radio detecting and ranging. So this kind of instrument is basically, first of all, it was used to detect the how much of above how much kilometer distance the aircraft are running. So, but nowadays this radar, it can be used to measure the rainfall data also. So here the transmitter is there. You can see there's this transmitter. They are producing the electromagnetic waves. Okay, and those electromagnetic waves, these are radiated by some narrow beam antennas are fixed there, as you can see. So those electromagnetic waves are radiated by those antennas, and this antenna, the same antenna, it will again interpret the reflection, whichever reflections are coming from these waves and from the target. So the receiver is there, and the receiver, it will detect and how much of it will transform all those these like reflections into the video and in the form of some indicators. And so if it is written there that if there is no target, the screen of the indicator is illuminated dimly and the screen becomes bright if there is a small target, and a bright patch if there is an external object such as rain. So like if the receiver, if there is no target, then the screen of the indicator, there is screen in the indicator which will illuminate it very dimly, and also the screen, it will become very bright. If there is almost a small target is also there, then the screen will become very bright. And suppose if extended object is rain, such as rain is there, then what will happen, the so this screen, it will have a very bright patch. Okay, so in this way this radar measurement of rainfall is working. So next is your last one you write down is your automatic radio reporting rain gauge. Automatic radio reporting rain gauge. You write it down, this one. Automatic radio reporting rain gauge. So basically your automatic radio reporting rain gauge. So what happens that in the mountain regions or in the hilly areas where you know like those are not, those places are not easily accessible. So in those kind of places, these automatic radio reporting rain gauges are used to collect all the rainfall datas. So like in as you have studied in the tipping bucket type of rain gauge, when you know like the bucket when the bucket rainfall is coming and the bucket will, it gets filled and then it tips and they give some electric pulses. So in this way, you know, at the receiving station, so these both signals are picked by UHF receiver. So there is a receiver, okay, which is your UHF receiver. So this kind of rain gauges, these are basically, these are used in the mountainous regions where the places are not easily accessible, okay. And in this kind of areas, your automatic radio reporting rain gauges are used. So you please write it down, the automatic radio reporting rain gauge. Okay. So I hope you have written the audiometric radio reporting rain gauge. So the rain types of rain gauges are finished. So next we will come to the types, or sorry, the selection of rain gauge site. So how you are going to select a rain gauge site or where you are going to install a rain gauge. Okay. So like here are some of the points that are mentioned here. So some of the following points are given here. So you can write this one also. Okay, you can write this one also. So let me first explain. So first point is that the site should be an open space. Obviously, the site where you are going to install the rain gauge, it should be a open space. Okay. Then the distance between the rain gauge and the nearest object should be at least twice the height of the object. So the distance between the rain gauge and the nearest object. Okay. So it should be what? It should be at least twice the height of the object. So whatever is the height of the object, the distance between the rain gauge and the nearest object, it should be twice the height of the object. Then the gauge should be placed on level ground, not upon a slope. So the gauge, it should be placed in a uniform level or in a uniform ground, and it should not be in a very, you know, like hilly type of areas or slope type of areas. So it should not be installed in such a place. So in hilly areas, if suitable level ground is not available, it should be placed on the top of a hill. So like I told that it should be placed in a level ground, but in hilly areas, if suppose there is no suitable ground is available, so where it can be placed? It can be placed on the top of the hill. Okay, then again in hilly areas, site should be best shielded from high winds where wind cannot form eddies. So eddies are circular winds, like you know. So in hilly areas where you know the rain gauge is placed, so those side, it should be, you know, shielded from all the sides, and it should be shielded from high winds so that the wind, it cannot form eddies. Okay, so again, now last point is your what? A fence, if erected to protect the gauge from cattle, should not be less than twice its height. So suppose in a since the area is an open space, the rain gauge should be placed in an open space. So there might be cattles. Okay, so what happened? A fence, it should be provided to protect the gauge from those cattles, and those fence, it should not be less than twice its height. Okay, so these are the 6 points for the selection of raingauge site. If you want, please write it down. Okay, selection of raingauge site, you can write it down, these 6 points. I'm giving you 5 minutes, please write it down. I hope you have finished writing. Okay, so let us go to the next topic. That is network of rain gauges in a catchment and their adequacy. Okay, so here the rain, here what is written here, you see, according there are certain recommended area densities for this rain gauges. So this according to the World Meteorological Organization, so the recommended area densities are, so there are certain area and densities for the network of rain gauges in a catchment and their adequacy. So here the rain catchment areas of gauges are very small as compared to real relating to area extent of the rainfall, and to get the average rainfall of the whole catchment for a particular storm, number of rain gauge stations should be optimum. So it also depends upon the topography of the catchment and its accessibility. So here you can see that the certain area, since area and densities are given, so let us see in how what kind of areas, what kind of area or densities are given. So here you can see, if the area is a very flat region, then there should be one station for 600 to 300 kilometer square. Okay, if there is a one is in a flat region, there one station should be for 600 to 3000 kilometers square. Then in a mountainous region, the station one station should be for 100 to 1000 kilometers square. Then in arid and polar region, so there should be one station should be for 1500 to 10,000 kilometers square. Then again for there is one IS standard, that is your 4987/1968. So according to IS standard 4987/1968, so in planes, okay, this one is according to your WMO. Okay, this one is according to WMO, World Meteorological Organization, this three. Okay, and according to IS, according to Indian Standard 4987 1968, so these three are there. So in plains, according to IS, one station should be for 520 kilometers square. Then in a region of average elevation of 1000 meter, a station should be there for 260 to 360 kilometers square. Then again in hilly areas where there is a very heavy rainfall, then one station should be for 130 kilometers square. Okay, so these three and these three. Okay, so these are the area densities that are recommended by your WMO, that is World Meteorological Organization, or your IS standard 4987 1968. Okay, so let us wrap up today's class up to here. Next, I guess we will be meeting physically in your physical class, that is from 27th. So let us wrap up here. If you have written, then it's good, and if you have not written, you can find this video in the YouTube, so you can later write it down. Okay, so thank you everyone. You may leave the class now.